Welcome back to Math 103. This is video number 20 on fair division. The lone chooser method is another fair division method for 3 or more players, and it's a different way of extending the thought process, the logic of the divider-chooser method to 3 or more players. So the idea is that initially there are just 2 players. This is one way to think about it. There are initially just 2 players, and what do 2 players do? They carry out the divider-chooser method. Right? They divide up the goods, whatever the goods are, in the usual way. Then a 3rd player shows up, and rather than start the whole process over again, they work forward from the result they already have from divider-chooser. In particular, player number 1, who got share number 1 here, is going to divide it up, subdivide it, that is, into 3 subshares. Player number 2, who got share number 2, is also going to subdivide that into 3 subshares. And that will enable the 3rd player, the chooser, to come in and select 1 subshare from player number 1 and 1 subshare from player number 2, according to the chooser's own preferences. So at the end of the day, player number 1 is going to end up with 2 of his or her own original subshares. Player number 2 will also end up with 2 of his or her own original subshares, and player number 3 will end up with 1 subshare each from each of these 2 original players. Here now is the official statement of how the lone chooser method works for 3 players. 1 player is randomly selected to be the chooser and temporarily leaves the room. He temporarily plays no role until the very end. Of the 2 remaining players, 1 is randomly selected to be the first divider. There are 3 stages. So at the very first stage, the 2 remaining players, the ones who are not the chooser, the ones who are still left in the room, apply the divider-chooser method between the 2 of them to split the goods into 2 shares that we call S1 and S2. In the second stage, subdivision, each of those 2 players, whom we now call subdividers, then subdivides his or her share into 3 equally valuable subshares. So 1 subdivider is subdividing his own share into 3 equally valuable subshares according to him, and the other subdivider is subdividing her share into 3 equally valuable subshares according to her. So as in the picture we saw on the previous slide, there are now a total of 6 subshares. Finally, the chooser returns and chooses 1 subshare from each subdivider. It is not okay to pick 2 subshares from 1 subdivider and none from the other. No, the chooser must pick 1 subshare from each subdivider. So each subdivider will keep his or her own 2 remaining subshares. Now each player has exactly 2 subshares, and these 2 subshares together are a fair share for that player. I'm going to say this again because it's such a common mistake that students make. When the chooser picks 1 subshare from player number 1 and another subshare from player number 2, it's crucial that the chooser choose exactly 1 subshare from each subdivider, and not 2 from the same subdivider. Okay, this is crucial to guaranteeing that both of the subdividers end up with fair shares. Okay, so let's see how this plays out in an example. For the sake of familiarity, and because the numbers work out reasonably nicely, let's look again at the same example we were looking at before for the lone divider method, the example in which Jason, Kelly, and Lauren are splitting up a timeshare situation. They share the rights to use a certain store location in the mall, but they have separate businesses, so only one can use the space at a time. Okay? And as usual in these types of problems, we agree in advance January 1st will be one of the turnover dates. Their preferences are exactly as they were before. Jason is the one who values each month equally. Kelly is the one who values each month, January through September, equally, but has no use for October through December. And Lauren is the one who valued January through September equally, but then October through December are each of those months is 3 times more valuable than a regular month. Suppose now that they use the lone chooser method instead of lone divider. Now there are a number of different ways that this could play out, because there are, I claim, 6 distinct ways in which they could carry out the method. Why 6? Well, there are 3 different possibilities for who the chooser will be. Jason could be the chooser, Kelly could be the chooser, or Lauren could be the chooser. And for each of these three possibilities, there are two cases, corresponding to who the first divider is going to be. That is, who's going to be the divider when they do divider-chooser in the first stage. So for example, you could have Jason as the chooser. That leaves Kelly and Lauren to play the other two roles. And between Kelly and Lauren, it could be that Kelly is the first divider, or it could be that Lauren is the first divider. So just with Jason as the chooser, there are two different ways to proceed. Similarly, with Kelly as the chooser, there are two different ways to proceed. And similarly, with Lauren as chooser, there are two different ways to proceed. So there are actually 6 different ways we could assign roles here. Now, this information about who plays what role, in other words, which player is the chooser and which is the first divider, that information will always be given to you. For our first run through this example, let's carry out the lone chooser method with Lauren as the chooser and Kelly as the first divider. Right, let's follow out the logic of this. So the first step requires Lauren essentially to leave the room and leave Kelly and Jason to apply the divider-chooser method just between the two of them. And we've been told in advance that Kelly is going to be the divider within the divider-chooser method. Before going on to the next video, carry out this first stage of the lone chooser method.